So my name's Andrew Fisher. I'm an interaction researcher, and today I'm going to take you on a device API safari for the next 15 minutes. So the device APIs are a big, broad set of quite small APIs that provide some really interesting capabilities to the browser. Originally, they were primarily aimed at mobile devices, but increasingly they're coming into our desktop browsers as well. Now, there's some big, really well-known parts of the device API that we all kind of think of when we talk about it. So things like device motion and orientation and stuff like that have existed for quite a long time now, and that's all we kind of think of when we talk about this. But there's so much more that we can play with. So today, I want to take you into some less well-charted territory. I want to show you parts of the device APIs where there's some interesting interactions that we can play with. But we need to be aware. It's a wild and dangerous place. There's moving specs all over the place. There's lots of busted implementations as well. But I want to show you the areas that you should be aware of now, so that you can start playing with them, so you can start using them, and start getting a much broader understanding of the rich experiences that we're going to be able to create over the next year or couple of years once these APIs hit the mainstream browsers. So to do this, we're going to explore this new land. We're going to start over here in the Wastelands, where specs change a lot, and sometimes they even die in front of you when you're trying to pull together a presentation. We'll then travel the wilderness, where some of the APIs settle down, they become a little bit more civilized. And then we'll finish over there on the plains, where browsers are better supported, and it starts to look a bit more familiar. So this is our map. This is where we're going. Let's start. So the first leg takes us through the Wastelands. Now, these are really highly changeable sort of proto-specs, I guess you'd call them, but they provide us some really interesting ideas about the direction our browsers are starting to go, and the future capabilities that we might have to play with. And if any of these are of interest to you, then feedback to the authors of the specs, because they're often looking for use cases to try and refine these things to get them into becoming drafts and things like that. So we'll cover these three areas. We'll look at the new sensor APIs. We'll talk about web NFC, and we'll also look at the network APIs as well. So the sensor API originally was supposed to be one big one, but it's actually turned into three smaller ones at the moment. So looking at temperature, humidity, and pressure. And these are being defined. They're sort of moving their way through the spec process, even though a formal implementation doesn't exist just yet. But there's a couple of interesting applications of this stuff once we start to get hold of it. So the first is being able to tailor content based around the conditions that that device is in. So I can pull the sensor data out, and all of a sudden I can tell whether or not it's stormy, whether it's nice, whether it's hot, whether it's cold, these sorts of things. And I can start wrapping content around that. So, for example, if it's a nice stormy day in Melbourne, then maybe I pull some content out and say, hey, here's 10 great things to do on a rainy day in Melbourne. And we can start getting that really hyper-local sort of content. The other application of this is a little bit more out there and speaks to some of my other interests, which is that with a pressure API coupled with the existing orientation and motion APIs, we can start pulling these together and have enough sensing capability to understand the altitude, direction, and acceleration of a web-controlled rocket. So this is going to really up the ante on NodeBots days, seriously. So the next beast on our Safari is web NFC. Now, who loves to hate on NFC? Yeah, there's a few. We've all done it. But one of the big problems that we've got is that for every connected device like this, we can't have an app on our phone. We are going to run out of space. We can't have millions and millions of applications for every connected thing that we're going to run into in our environments. So web NFC might actually help this out a little bit, because what this means is that by tapping my phone on one of these little tags, that can provide me with a web interface to be able to configure that device or consume the data that's coming out of it. And I don't need to install an app. It gives me that just-in-time capability to configure or interact with the service that it offers. So this is a much more scalable way, and it sort of moves the web back to being the heart of our interactions with these internet-connected things. So WebNFC is in draft stage at the moment, but it's moving really rapidly. So if you're interested in smart things or kind of Internet of Things, then keep an eye on this because it's actually got a lot of community support and it's moving very rapidly. Now, before we leave the Wastelands, we're going to touch on the network APIs, and this image pretty much sums it up at the moment. One of the specs actually got shelved, even though there was a working implementation of it just a week or so ago. So this is still very movable ground. But there's a couple of areas that are still worth looking at. The main one being the Network Service Discovery API. So if you're familiar with MDNS or Bonjour, this basically brings Bonjour to a web browser. So again, giving us that ability to start consuming and interacting with services that exist out on our local network and being able to interact with them directly, which again provides the web browser as being that center point of our interactions with networked objects. So let's leave the wastes and move on. In this part of the wilderness, we're going to look at some of the APIs that are starting to settle down. We can actually play with these ones a little bit more and start getting an understanding of what their capabilities and potential might be. So here we're going to look at proximity, and we'll also look at the battery status APIs. So first up is proximity. Proximity API gives us two new events that fire for us, and these actually both fire at exactly the same time, but give us slightly different pieces of information. The device proximity event just gives us an object that tells us how close someone has got to the thing that's got the sensor in it. It also gives us some information about what's its detection range, how far and how close does something need to be in order for it to be detectable. The user proximity event fires at the same time, like I said, but it's super, super simple. It just tells us if something is inside that detection zone. And we can use these two things to kind of tell us different pieces of information. So really, really simple to play with. This is an example of it working. So you can see as I move my hand kind of near and far away from the device, it just tells me that I'm inside that proximity zone. Now, at the moment, the proximity detection of most devices is about 5 or 10 centimeters, and that's because it's designed to detect your head when you put it up against the screen. But the spec doesn't imply any particular restrictions on this. So the good thing with that is that it means that, say we had, say, like a kiosk type device, as people are milling around, it could be sitting there in some sort of attractor mode, but then as I get within sort of arm's distance of it, then it might flip into its interaction mode. And I haven't even had to do anything. I've just walked into its space that it can detect in. And these are the sorts of things that we could use the proximity API to start doing for us. From here, we'll have a look at the battery status API. Now, as we go more and more and more mobile, even as we shift from desktop computers to laptops, we need to be much more cognizant of people's current energy state. The last thing you want is for you to be the thing that causes someone's laptop fan to start whirring like a helicopter or their phone to go super hot in their hand when they've only got 5% of their battery left. You watch how quickly that tab is going to be closed down. Now, this API can help you with that. Support for it is pretty solid. It's available in all the various flavors of Firefox. It's in WebKit, making its way through there, and it's in Canary. So this is sort of on its way now. So it gives us a bunch of new events that really are around tracking the charging and discharging states of the battery, as well as whenever the battery changes its state as well. For all of these, we get this battery manager object, which is identical for all of those different events, and it just tells us whether the device is charging, whether it's discharging, how long it's got to go until it's fully charged or fully flat, and what the current percentage level of the battery is. So we can all use all of this to start shaping the experience for our users. So say someone's on battery and they've only got 20% of their charge left, we can throttle back our network calls. Maybe we poll in kind of batches every minute or every couple of minutes rather than having a stream. Likewise, if someone's connected to mains, then we can push the boat out. We can kind of start switching on WebSockets. We can start using the accelerometer, which will just burn through your power, no problems, and start using things like the GPU for animations and stuff like that. So we can start shifting the way that this experience works. So proximity and battery status give us some interesting ways that we can create much more responsive experiences for our users based on their conditions that they've got around their devices. So let's leave the wilderness behind and go somewhere to start that looks a bit more like home. Last part of our safari today is to look at two more APIs. They're both quite stable. You can start using these from a progressive enhancement point of view right now. And these are vibration and the ambient light APIs. Vibration is dead simple. Basically, you tell the navigator to vibrate for a period in milliseconds, just like that. If you want to get fancy, you can use it like this and tell it to vibrate under a pattern of kind of on and off sequences. And then if you want to switch it off, you just pass it as 0. So really super simple API to play with, but you can do some interesting things with it. So the immediate applicability of this is to use it in things like gaming for being able to provide feedback. Now, this is obviously quite tactile, so if you want to go to that URL, you can actually play with this, and you'll see the kind of phone vibrate. This will work in Chrome for Android, and pretty much all the implementations of Firefox, but you need a vibration motor in your device in order to kind of get the full effect. Otherwise, it will just, not do anything. But we can do more than this. So we could start using vibration to signal some kind of attention that is required on the device. So for things like forms on mobile like this, as you all know, once you activate the virtual keyboard, you lose a huge portion of the viewport, so it's easy to miss things. So we can use vibration in conjunction with our traditional kind of ways of using color and message to alert somebody that they might need to take some sort of action. So we can use this right now to start playing around with this sort of thing. The last one that we're going to look at is the ambient light level event. Now, the only sound implementation of this right now is in Firefox, but it's very robust. It works across all devices, and it's starting to make its way through the other platforms as well. Now, this event fires every time the light sensor in your device detects a change in the ambient light levels. And then at that point, the device light level event fires, and it just passes us back a value, which is the amount of light in lux that the sensor's capturing at that point in time. So really simple API. Now, as humans, we have this incredible range of light levels that we can see in. However, the problem with that is that these adaptations don't work sometimes in the modern world. So in bright sunlight, we start ending up with things like we can't see contrast very well. So you'll all be aware of trying to look at a screen in bright sunshine and it washing out. Likewise, trying to look at a bright screen in almost darkness can almost be painful to look at. You have to start squinting to kind of see the screen. So we can use the ambient light levels to help out here. So as the light levels change, we just pass in a rule that changes a class on the body tag to cascade a whole bunch of different CSS rules to apply. And so now we can start shaping the colors and things like that we're using to compensate for these varying light levels. And you can do this now. This will work in Firefox quite happily. Now, it's quite a worthy use of the technology. Obviously, there's a more frivolous way that we can use this as well. So here I've used the API to control the images that you'll see around my head, depending on the light level. So it starts off all fun and happy and bright, and then as it gets darker and darker, it gets spooky and creepy. So you can kind of start seeing how these things can be played with to create some interesting interactions. So that's brought us to the end of our safari. we had a look at some of the wider, wild areas of the API before we started looking at how battery and proximity, you can start using those to create much more responsive experiences. And we can start using things like vibration to help with feedback and ambient light to really start refining that experience for our users. All of the code that you've seen from my examples, as well as reference implementations and things like that, and the quirks notes are all up in my GitHub there. And if you've got any questions, then hit me up or ask me on Twitter or via GitHub. So, thanks a lot.